Okay, so now let us discuss some special question about the combination. Actually, not really hard also for all this question, just that you need to on the correct track of finding out the answer or try to think in the correct way. If not, you cannot get the answer. All right. Okay, so let's have a look at example 20. Okay, so example 20, they actually describe what happened to the question here. Okay, so they say that there's a lock on the door for each room can be opened by a key card, inserting the key card, and then the key card can be inserted only one way round. The card has a pattern hole punch in it, so it has 4 columns. So as shown here, you have 4 columns here for one key card, and then each column can have either 1 hole or 2 hole or 3 hole or 4 hole. So every single column here can have either 1 or 2 or 3 or 4 holes. It cannot be 0, it cannot be 5 holes, cannot be 6, cannot be 7. Okay, so the number of holes that being punched in the first column can be either 1, 2, 3 or 4. Okay, and then for each column has 8 different positions. So every single box here means 1 position. So 1 position, the second position, and so on. And then after that, the diagram here actually shows you a key card with 3 holes in the first column, 3 in the second, 1 in the third, and also 2 in the fourth. So they are talking about the number of the key card here and also the hole. Okay, so how do you answer the question that they asked here? Okay, so first part they're asking, show that the number of different ways in which a column can have exactly 2 holes is 28. Okay, so for first part, they ask you how many ways can I punch 2 holes in one column? Okay, so to punch the 2 holes, they didn't mention any particular 2 holes. That means the arrangement is not important. As long as you got 2 holes in a column will do, right? Okay, so since you're having 8 different positions in the first column, and you want to punch only 2 of them, so it should be 8C2. So from the 8 columns here, you choose 2 and punch them. Alright, so when you press for add 8C2, you should get 28. Alright, so they already tell you the answer is 28. So that means if you can, by try and error, you also need to try to figure out how to get the 28. So if you try and error, you can see that it is 8C2. Okay, so this step is very important. Alright, so why is it very important? It is because of if you successfully figure out the correct step here, that means very likely you will use the same step again to answer the second part and third part. Okay. All right. So let's have a look for part number 2. How many different patterns of hole can be punched in the column? Okay. So for one column, you might have a few different cases. So the first case is in one column, maybe you punch only 1 hole, so it's 8C1. In one column, it should be, you can also punch only 2 holes, so 8C2. You can punch 3 holes, so 8C3. Then you might punch 4 holes also, so 8C4. Okay, so all these are the complete case because for one column, you might have 4 cases only. Either first case is 1, second case is 2, 3 case is 4. Therefore, you plus them. Okay, so when you want to plus them together, you should get 162 here. Alright, so you can see that I'm trying to use the step find out just now. If let's say a column, I want to punch 2 holes, so it's AC2. Therefore, when I want to consider for 1 hole, 3 holes, and 4 holes, I'm using the same method, AC1, AC2, AC3, and AC4. Okay, then after that, continue to part number 3. Okay, so for part number 3, how many different possible key cards are there? Okay, so now I want to find out the number of key cards, the possible key cards. Okay, so how can I have a complete key card? So to get a complete key card, you might have 4 columns. Alright? Okay, so for one column, how many different types of pattern you might have? One column you have 162. Second column you also have 162. Third column is 162. Fourth also 162. Okay, for each column here, you might have 162 different patterns. Okay, and after that, if you want to make it as a complete key card, because this one is one column, right? So one column cannot make it as a complete key card, so it is not a complete case. So to make it a complete key card, you have to multiply all the 4 columns here to make it as a complete key card. Alright, so for this part, the answer that you get should be 6887 47536. Or you can change it become 3 significant figure, which is 869000000. Okay, so this is how we do it. Alright, so all this question, right? Actually, maybe when you look at it in the exam for the first time, you'll feel panic because it looks a bit complicated. Alright, so of course, if let's say you try more, then you answer this in an easier way. I mean, at least you won't feel so panic when you see a question. If you practice more, maybe you tried similar question before. Okay, so this is all you have for example 20. Okay, so let's continue to example 21. Okay, so for example 21, wow, this looks great. Okay, so I'm having a menu for a meal in the restaurant as follows. Okay, so maybe I will make it smaller so that you can see how I do the calculation. Okay, so here, what they want actually. Okay, so let's have a look for the question here. They are asking, how many different course meal are there? Okay, so how many different 3-course meal are there? There, 3-course meal. Okay, so that means when you look at the menu, right? Okay, so when you try to order, okay, it should be, you choose one from starter, one from main, one from dessert. Right or not? And after that also, maybe you have to read the detail very carefully. All the main course are served with salad and either new potato or French fries. So you will see that there's another selection for you here. You choose either new potato or maybe the French fries. Okay, so now I want to form the number of different course meal. Okay, so for starter, how many starter you have? 3 types. So for the 3 types of starter, you choose only one. Okay, and then to make it as a complete course, you have to multiply. Then now, consider the main course. So for the main course, what do I have? So I'm having 1, 2, 3, 4, 5, 5 main course. So 5 main course, you choose only one, but I need to multiply it with 2. Why do I need to multiply it with 2? Or maybe I can multiply it with 2C1. Okay, so this is for main course. This is starter. This is main course. So why do I need to multiply 2C1? It is because of from the main course, you can also choose either you want new potato or you want to choose the French fries. So 2C1. Okay, so after you select the main course already, then now the next one you want to select the dessert. So for dessert, how many selection you have? So you have 3 different types of desserts here. You want to choose only one, so 3C1. Okay, so to make it as a complete course, you multiply them together to get a 90. I think right? Okay. Then second part, how many different choice are there if customer may choose only 2 of the 3 courses? Okay, so now you are having 3 courses here, starter, main, and dessert. But now they change the rule a bit. They say, okay, you cannot have all the 3 courses here. You can only have 2 courses only. Okay, so if you have 2 courses, there are a few different cases that you need to consider. The first case is you might have starter and main. Okay, and then the second course, the second possible result is you might have starter with dessert. Okay, like some girls, right? They don't like the main course one. They don't like the meat. They don't like the fish. They only like the starter and dessert. So maybe for some girls, they will choose starter and dessert only. Then maybe for the third possible case is you might have main and also dessert. You don't want the starter. So all these are 2 courses. Okay, so 2 course meal. Okay, so for first case, when you have starter and main, what do you have is 3 starter, you choose only one and multiply with main. Main is 5C1, multiply with 2C1. Okay, so this is the first case. Second case is starter and dessert, so 3C1 multiply with 3C1. Okay, then for the main and dessert is 5C1 multiply with 2C1. So everything with main course, you have to consider the 2C1 also, because for the main course, always they give you a selection of either new potato or French fries. And then multiply with dessert, which is 3C1. Okay, so all these three are the different cases. So to get the answer, you add all of them together. Right? So if you add all of them together, if I'm not mistaken, you should have 69. Okay? Alright, so again, you might need to do some sorting. That means you need to list out all the possible cases before you can find the answer. Okay? Alright, so this is what we have for part number 2. Okay, then now we go to part B. So part B usually will be different from part A. Part B will not be related to part A. So part B is a new question here. In how many ways can a group of 14 people eating at the restaurant divided between 3 tables sitting 5 by 4? Okay, so here you need to consider originally you are having 14 people and you want to separate them into 3 different tables. Okay, so let's say, because no matter you select 5 people first or 4 people first, it doesn't matter because the sequence is not important. You just want to divide them only. Alright, okay, so if let's say you are having 14 originally, you want to choose out 5 of them and put them in the first table. Okay, so after you put the 5 in already, how many people left? You left 9 people. So you want to form another table, right? So you choose 9 and then you choose 5. So you choose another 5 people and put it into the second table. And the remaining, you still have 4. So 4 of them, you choose all of them to put it in the third table with 4 people. So when you try to multiply it, you have 2, 5, 2, and 2, 5. So people will ask like, why do I need to multiply? Can I choose plus or not? Cannot. Right. So why do you need to multiply? Because they are a group of complete people. And this group of people, you want to arrange them in 3 tables. So to make sure that they are complete in the thing, so you have to multiply, but it cannot be a plus. Okay? Alright, so these are the 2 examples that I will want to discuss with you. Okay, but of course, in the real exam, they might have more special type of question. Okay, so again, still the same thing I want to say, just try out as many questions as possible for your past year or maybe a tutorial question so that you gain experience from that to know how to answer different patterns of the question. Alright, so you see that here we ended our chapter 2 already for statistics. And then for next video, we are going into chapter 3. So the chapter 3 is about probability. Okay, so probability is an extension from this part also, and the probability is also a chapter which is quite difficult because a lot of students told me that same like this, they know the idea, they know the concept when we discuss it in the past, but actually in exam when you want to apply it, it is not as easy as you think. I agree with that also because currently until now, right, if let's say sometimes I try out some probability question, sometimes I still need to think quite long to get the answer. Alright, so it does not guarantee that you confirm can get the answer correct, although your concept is there, your technique is there. Alright, because the way of thinking, okay, to answer the question is also very important. Alright, so I will stop here for this video. Okay, so see you in the next video for probability.